All right, lesson 39 is on using distributive property to simplify rational expressions. So we're just going to jump right in, and actually I'm going to give you as a little rectangle, and let's make it colorful with some purple. Oh, that's my favorite color. Okay, so we are going to be distributing this term, this outside term, this r squared over q, to the two terms inside the parentheses. So we actually are going to ignore half of the parentheses at a time, and that's what I've made this little rectangle for. Okay, so I'm just going to ignore this. So I'm just going to look at the first two, and when I multiply the tops, I add the exponents. So I get r to the fourth. And when I multiply the bottoms, I'm going to add the exponents, and I get q to the fourth. Okay, I have a plus sign, so I'm going to write my plus. And now I'm just going to ignore the first term now, and I'm going to do the same thing on the second term. So I have 7, I have a r squared and a q to the third. They are not the same variable, so I'm not going to combine their exponents, and so I'm just going to rewrite both of them. Over, now in the denominator, I have a q and a w, and they are not the same, so I'm going to put q and w. The next step, and the last step I need to do, is make sure that I don't need to simplify anything in each of the terms. So r to the fourth over q to the fourth, different variables, so I can't do any simplification with them, so I just rewrite them. Okay, in my second one, I have a q to the third on top and a q on the bottom, which is really a q to the first. So I can simplify those. Those are going to be the only ones I can simplify, so I can rewrite my other terms. So if I have q to the third on top, that means there are 3 q's and a q in the denominator. So one of them will cancel, and I'm left with a q squared on top. I also look at this and say I have q to the third on top and q in the bottom. Which one has more? Well, the top has more. How many more? It has 2 more. So I have q squared in the top. Now this is my answer. I cannot combine these two terms because they have different variables. All right, so let's do the same thing, and let me go back and get my lovely little purple rectangle. All right, here we have it. So now let's do the same thing here. We're going to ignore the second term. So in the first one, I have none of the same variables on the top, so I'm just going to rewrite them. And in the bottom, none of them are the same, so I'm just going to rewrite them. Minus. Now I'm going to move over my rectangle. All right, now this is really in the numerator, and I have it over 1. So I have t to the third, and I have a t to the first. So that gives me t to the fourth, and I have my y squared. Now on the bottom, I just end up with a z. Okay, so now we're going to look at each of the terms and see if there's anything I can simplify, and I can actually cancel out my t's. So I end up with u, a, y over z, q. None of those are the same, so I can't cancel. In my second term, I don't have any of the same variables, so I can't cancel. So I'm just going to leave it as is. These are not like terms because they do not have all the same variables to the same exponents, so that's where my answer stays. All right, more of the same, ladies and gentlemen. This time, though, we are going to see that we are including negative exponents. So ignore that first one. I have j to the negative 2 and j to the negative 3. Same thing, I'm going to add the exponents. In the bottom, I have an m to the first and an m to the negative 2. I'm going to add my exponents, and I end up with m to the negative 1. Okay, we'll come back and take care of those negatives here in just a second. Okay, so now let's look at the second one. I end up with a 9, m to the third, j to the negative 2 over mk. Okay, so now we can look at simplifying. Now I have a negative exponent, so that means if the negative is in the top, it goes to the bottom and it becomes a positive exponent. When the negative is in the bottom, it's going to move to the top and become a positive exponent. Now I have a 9. Okay, now I look at my m's. I have an m to the third on top and an m in the bottom. Well, m to the third is bigger, so I have 2 m's on the top. I have a j with a negative exponent, so that's going to move to the bottom and become positive. And then my k stays down there. These are not like terms because they do not have all the same variables to the same exponents, so I leave it as is. All right, let's tackle another one. This one is the same type of idea with having negative exponents. Let's make that a little bigger and smush. There we go. Okay, so I don't have any of the same variables in the first one, so I'm just going to write them all together. And z and v to the negative 1. We're going to take care of those duplicate variables and the positives and negatives in a moment. Swap it over, put this over 1. Okay, 4. Oh, I have an n to the 5th and an n to the negative 2, so when I add those, I get n to the 3rd, and I have b to the negative 3 over a z. All right, so now let's go ahead and simplify each of these individual terms. Now I have a negative exponent, so I'm going to move this down, but I already have a 1 there. So when I move it, it becomes positive, and I have a 1 there. That makes, so I have an n squared and an n to the 1st, so I can add those, and I get n to the 3rd. Okay. V, I have a negative 2, so I'm going to move that down, but I have a negative 1 there. So I end up with a v squared and a v to the negative 1, so I can add those and I get a v. My c, my b, and my z all stay as is. Okay, and in my second term, the only thing I have to take care of is this b to the negative 3rd. It moves down to the bottom and becomes positive. And now I look at it, no like terms because they do not have the same variables to the same exponents. All right, now this one, same idea, except it has 3 terms. We're not doing anything different with it though. Okay, so just ignore these 2 terms, the second 2 terms. Okay, so I have an f and an f, so I get f squared, h, and then I have 2 s's, and I end up with d to the 5th. Okay, so now I'm going to ignore my first term, and I'm looking at my second term, put it over 1. So I have 2 f, I have 2 s's, so that becomes s squared over k, or with k, and then over d to the 4th. And now I'm going to ignore my first 2 terms. I'm going to look at the second one, minus 7fs over d to the 10th. Let's see if we can simplify anything. My first term, I don't have any negatives, and I don't have any duplicate variables. My second term, no negatives, no duplicate variables, and my last term, no negatives, no duplicate variables. So even though it looks long and yucky, that's my answer, so leave that there. All right, oof, one more like this. It's good practice for us and easy free answers. Okay, so ignore the second 2 terms. I have a z and a z, so it gives me z squared. D to the negative 2, and then I have 2 x's. W, remember this one has a 1, so this is going to give us w to the negative 1 when we add them. We'll move this over, put this over 1, so plus 5t, there are 2 z's, so that becomes z squared and an x over w to the negative 2. And now you're going to ignore the first 2. We're just going to focus on the last one. So minus 2zx over w to the negative 6. Now we're going to do some simplifying. In my first term, you have each variable only once, but I have some negative exponents. So my z stays, my x stays. My w is going to move up and become positive. My d is going to move down and become positive. My second term, everything is a single variable, and I just have this negative to take care of by moving it up. So plus 5t z squared x w squared. And then in my last one, again, I just have the negative to move up, and it becomes positive. These are not like terms because they all have their own variables. All right, last one. I know this was a little long today, guys. A regular canvas is to be painted. The area of the canvas with length, and there's that expression, and a width of that expression is represented by this. And this is just saying length times width. Here's our width, here's our length. Simplify the expression. All right, so we have a t squared and a t to the negative 3. I know it's a little hard to see, but if you open your books up to page 246, you'll see it there. And a y, and on the bottom we get a y to the negative 2 and a z. So now we're going to look at the second term. We have t squared y z to the negative 4th. Nothing to combine there. And on the bottom we have nothing to combine also. Okay, so we're going to simplify each of those by getting rid of negatives. And here I see I have 2 y's. Now this one's going up and it's going to become positive. So I have a y squared and a y on the top. So that's going to be a y to the third. This t is going to go down and the z stays there. All right, here I see that I have a y on the top and y to the third on the bottom. Well, which one has more? The bottom has more by 2. I see I have t and a t squared. The top has more by 1. And then this one is going to go down and become positive. So I have a z and a z to the fourth in the denominator. So that gives me a z to the fifth. These are not like terms because they have not the same variables to the exponents. All right.